So before you work on it should we work on it for 2 minutes? Do we actually have time? All right, it's a little tight. So I'll just do it for you guys. We'll work on it together. Okay, so in this problem, we're given the derivative of revenue, right? Marginal revenue. So already you should recognize this as IVP. This is already jump out at you. That's an IVP. Why? I gave you the derivative and I gave you a point. So that's already an IVP. So at some point, you're going to have to solve that IVP. Now, this question originally did not have a part A. It just had part B. I'm putting part A there to kind of scaffold you guys, right? So even if part A were not there, you would have still needed part A to figure out part B. But I'm putting that there to kind of give you a hint for the problem. It's called scaffolding. It's a teaching technique. One day when you grow up, you can do it too with your students. First of all, the demand function, that's just the price function. That's just another name for the price function, so P. So my first question is, what does the given information have to do with P? Do you know any relationship between these things?
We know that R of X is equal to X times P of X.
Okay, good. So we should definitely remember that, right? What is the total revenue is equal to the number of units you have sold times the price you have sold them at. Duh. So already I can see if I want to get price, I can also just get revenue, right? If you have one, you have the other. So the information I gave you is absolutely relevant because that will actually then give you the price. The only caveat is what? I actually have to get the original revenue R, but I'm only given the derivative. So that's where the IVP comes in. Right. Okay. So let's solve the IVP for revenue. And just to be clear, although I think it should be clear from the statement problem, what are the two pieces of information? We're given a derivative. And we're also given a point, right? R of 0 equals 0. And that's a pretty safe assumption, right? If you don't produce anything, you don't make anything. All right, and how do we go about solving this? Well, we start with the first equation, right? We start with condition number 1, and we find the antiderivative of that to get back R. Okay, now just to make sure everyone is kind of playing along and we haven't forgotten power rule, can someone just give this antiderivative to me very quickly? Someone have it?
Negative x cubed plus x to the 5th over 5 plus 84x plus c.
So I think you may have copied down, I think you probably copied down x to the 4th. It was actually 4x.
Yeah.
So who wants to correct Peter? He just copied down the wrong thing. So it should be what as the second term?
2x squared.
Yeah, 2x squared. Okay, so now we actually have to find the plus c, right? Now we've used condition 2 to find the plus c. I will also say I don't necessarily like C because C sometimes with business problems, you might get it confused with cost. So maybe use K or something else, although K can also get confused with capital. But I mean, this problem doesn't have cost, but please, if you are doing a problem with cost, if you're already doing a problem where there's a function C of X, don't use plus C for the notation, please. I mean, it's not like I'll mark you wrong because I know what you mean, but please, come on. All right, so according to this, what do? We plug in 0 into my revenue function. That's R of 0. But I'm supposed to get out 0, right? That's what condition 2 tells me. Now this looks pretty easy, right? Because we just get a whole bunch of zeros. We just get 0 plus k has to equal 0. So k was actually equal to 0. So coincidentally, if you forgot about the k altogether, you would have still gotten the right answer. Okay, and now we're done with the revenue. So our revenue and price functions are the following. I have my revenue. And I have my price. Remember, price was what? Revenue divided by X, right? That was what we talked about at the very beginning of the problem. Okay, whew. Finally. Jan, are you bored? You excited? You like this problem?
I've never been more excited, to be honest.
I love it. Yeah, IVP problems aren't the most exciting, to be honest. But they're okay. Now let's look at part B. So part A was the new material. Part B is actually old material. Part B is something that if you knew the answer to part A, you should have been able to figure out part B. You could have done this last week. Part A is the stuff we did new for today's lecture. So why is part B old material? What is the market price if revenue is at a maximum? We just did this last Friday, right? We talked about mins and maxes, right? What was the main thing about mins and maxes? Where do mins and maxes occur? Where can you get a min or max of a function? There was a theorem that actually told you. Someone was about to talk.
And the derivative of the function equals 0 or does not exist?
Right, exactly. In other words, max and mins can only occur at the critical points, right? Which is where the derivative either does not exist or is equal to 0. So in this case, if I'm asking where revenue is at a maximum, that means I want the derivative of revenue to be 0. So if I set the derivative of revenue to be equal to 0, I can get the x value, right? And then from that, I can get the corresponding market price. But that's the principle that we're using here from last Friday, right? That local maxes and local mins occur at critical points. Okay. So let's write that down and then finish the problem. The maximum occurs where r prime of x equals 0. So this actually can be factored, I mean, over the rational numbers, I mean. So we get negative x minus 6 times 3x plus 14. All right, this is just some simple algebra. We get x equals 6 or x equals negative 14 over 3. You can't produce negative iPads, so that I mean you can't have x as a negative number. You can only use positive numbers for x. So x equals 6. So this just tells you if you want the revenue to be a maximum, you should produce 6 units. But the question actually asked, what should the price be? So I need to take my x equals 6 and put it back into my price function from the previous part. So P of 6, and you should get 60. Yes.